Okay, so we're starting Chapter 3, Lesson 1 on graphing linear equations. And a linear equation is an equation with an x and a y variable, an independent and a dependent variable. And whenever you graph the solutions to that, it forms a straight line. There's no curves or anything to it on a coordinate plane. So we're going to just start kind of talking about that today. We've already gone over slope and slope-intercept form and point-slope form. So the third type of way to represent a linear equation is with standard form. And standard form looks like this: ax plus by equals c. And in point-slope form or slope-intercept form, slope is m. So whenever you see the variable m, it stands for something. And then your y-intercept would be b, in y equals mx plus b. In point slope form, you've got an x and a y coordinate that's a solution to the equation, and you've also got your slope. Here, none of them mean anything, right? You have your x and you have your y. So we could rearrange this to get y by itself and put it in slope-intercept form, but there's no standout, it's not like c is your y-intercept or something. It's not. A, b, and c don't stand for anything specific. So they're just numbers, and you can manipulate them to find things you need, but none of them represent slope or anything. Okay, so to determine if an equation is a linear equation, it tells you that you have to be able to put it in standard form. And you do. That is true. You have to be able to rearrange an equation to put it into standard form, okay? A, B, and C are just numbers. That's all they are. They're just numbers. So you could have x plus 3y equals 4. And the number in front of x would be 1. The number in front of y would be 3. And c would be 4, right? A, B, and c just represent the numbers here. There doesn't have to be a number. If there's no number, we know it's a 1. And then if there's no variable, like if I just had 6y equals 18, b would be 6. A would actually be 0 if there's no x term, right? We'll get into that. Anyways, this is standard form. So if you can put this equation in standard form, it is linear, but there's a quicker way that you can kind of shortcut it. The terms in an equation, and terms are always separated by plus and minus and equal signs, only have one variable and no exponents. So for example, in this guy right here, see if I can zoom in on it and see it better. 3xy plus y equals 4 plus 2x. All of this looks okay except for this term right here. Terms are separated by plus and minus signs and equal signs. So we've got that term, that term, that term, and that term. These are all terms, right? A term can only have one variable. So that has one, that doesn't have any, that's fine. That has one. This term has two variables, right? X and y are getting multiplied together. In a linear equation, that cannot happen. So this would not be a linear equation because 3xy has two variables in it. So terms, x and y's have to be separate. Doesn't matter what number's in front of them. You could even have one missing. That's fine. You could have y equals 8. That would be a linear equation, a linear horizontal line. A horizontal line when you graph the equation. You could have x equals 12. That would be a vertical line. So you can miss an x or a y, but you cannot have x's and y's being multiplied together. That's a big no-no. And the other thing is you can't have an exponent. Exponents can only be 1, and that's it. And when they're 1, you don't even write them. So if you see x squared, that equation is not linear. So that's your shortcut. Terms, which are separated by plus, minus, and equal signs, can only have one variable at tops. They don't have to have any, but they can't have more than one, and there can't be any exponents. Okay? Beyond that, everything else is just, playing around with it. If you can put it in standard form, great, but you don't even have to do that. Okay? So let's look at a few. 2x equals 4y. 2x is a term separated by an equal sign from 4y. So there's no exponents, and each term, I can circle them, each term only has one variable. So yes, this is linear. Okay, then it tells us if it's yes to write it in standard form. It tells us write it in standard form. So we have to put this in the form ax plus by equals c. So we have to get both terms on one side of our equal sign, and then any number that doesn't have a variable, that's our c value, alone on the other side of the equal sign. So I want to move 4y over here with the 2x. So to get rid of it, I'm going to subtract 4y, subtract it from here. These go away, and I'm left with 0 equals 2x minus 4y. This is in standard form. ax plus by equals c. A would be 2, b would be -4, and c would be 0. This is in standard form. So you want to get your x's and your y's on one side of the equal sign and any other plain number with no variables on the other side. Okay, next we have 2. So we've got this term, we've got this term, and we've got this term. Do any of those have exponents? No, they do not. Do any of them have more than one variable? No, they do not. So yes, this would be a linear equation. Now we have to get it in standard form. So I want to get x's and y's on one side of the equal sign, any other plain numbers on the other side. So this x, I need to subtract it, and I'll be left with y equals 2. And I'm done here. This is in standard form because this is in the form ax plus by equals c. Where did I write this? Oh, over here, sorry. A is 0 because 0 times x is just 0. It cancels out. B, the number in front of y, is 1, and c is 2. So this is in standard form. Even though it doesn't look like it, we don't have an x term because it got canceled out. So everything else is in standard form. We have our y on one side of the equal sign and our plain number on the other side. Okay, let's look at number 6. We've got terms, we've got y, x squared, and 7. And hopefully that stood out to you because yes, we have an exponent. So no, this is not linear. This would be a curved, like a parabola or something. Would not be a linear equation. You cannot have an exponent. Okay, then we've got this guy, x plus 8 equals 0. We've got 3 terms. None of them have an exponent. None of them have more than one variable. So yes, this is linear. So we need to get all the variables on the left and all the plain numbers on the right. So I'm going to subtract 8, and I'll get x equals -8. So this is in the form ax plus by equals c. X equals -8. So the number in front of x, a, is 1. B has to be 0 since it canceled this whole thing out. Oops, sorry. Number in front of x is 1. This whole term got canceled, so b has to be 0. And c is -8. This is in standard form. I know that's confusing, but it is. Variables on the left, plain numbers on the right. Okay, then we have this guy, which is similar to the example we did up top. We've got 3 terms. We don't have any exponents, but this term has more than one variable. X and y are being multiplied. So no, this is not linear. And a few more here. 4 more. Okay, number 10. I've got 1, 2, 3 terms. There's a plus sign here and an equal sign. No exponents, and none of the terms have more than one variable. So yes, this is linear. Now, I'm going to show you a little trick to this. There's another thing you have to know about standard form, and this is a good example of it. So for standard form, remember we have to get x's and y's on one side of the equal sign, any other plain numbers on the other side. So I'm going to subtract 2. So I'll have 1/2 x equals y minus 2. And then I need to move this y over here. So I'm going to subtract y from both sides of my equal sign. And I get 1/2 x minus y equals, what, -2? All right, so here's my equation, ax plus by equals c. Fantastic. But the other rule for standard form is that you cannot have a fraction. A cannot be a fraction, okay? Really, none of them should be a, b, or c, but the rule is that a cannot be a fraction. So how do we make this not a fraction? Well, I have to multiply by the denominator to cancel it out. But I can't just multiply this term by 2 because then I'm just changing this term. I'm not keeping everything equal. So I'm going to multiply this entire side by 2, and I have to multiply this entire side by 2. Let me do it on a separate sheet of paper because it's getting a little confusing and messy. All right, so I have a 1/2 x minus y equals -2. The first number here cannot be a fraction, so I have to multiply this entire side by whatever the denominator is, and I have to do the same thing over here. Okay, so now if I distribute this 2 times 1/2 x is just 2/2x, which is 1x, minus 2 times y is 2y, and then -2 times 2 is -4. So this is the same thing as this, but now we don't have a fraction in the front. So whatever your denominator is for A, you're going to multiply this entire side by that number to get rid of the fraction. Okay? If it was like 2/3 x minus 4y equals 6, let's say, right? That's just an example if it looked like that. To make this not a fraction, I just have to get rid of the denominator. I don't have to get rid of the whole thing. I just don't want a denominator. So I would multiply everything by 3. Same thing over here. 3 times 2/3 would be 6/3, which was just 2. 3 times 4y is 12y, 18. When you multiply 3 times 2/3, the top and the bottom just get canceled and you're left with the top. Right, so now this is the same thing as this, but I just don't have a fraction in front now. Okay, hopefully that makes sense. All right, so up here we have x minus 2y equals -4. So I do want to go back up to the top of your notes here. And for standard form, I want to make sure that we understand. Here, I'll write it up here. Standard form. A cannot be negative, it has to be positive, or a fraction. So that number in front of x cannot be negative and it cannot be a fraction. Okay, we got 3 more to do. Zoom back in. 6x plus 4y minus 3 equals 0. This term, this term, this term, this term. Sorry, it's kind of written over. None of these have exponents. None of them have more than one variable. So yes, this is linear. And then to get x and y on one side and any other numbers on the other, I have to subtract 3. Oh, is it already minus 3? I have to add 3 on both sides. So 6x plus 4y equals 3. And the number in front of x is not negative and it is not a fraction, so this would be your answer. This is in standard form. ax plus by equals c. Excuse me. Here we have 1, 2, 3 terms. We have 2 variables in this term, so this is not linear. And then lastly, we have this term, this term, this term, and this term. However, x squared here has an exponent, so this is not linear. All right, hopefully that's making sense. Let's do one more where we have a fraction and we have to change it. Here, this guy. This is linear because x and y are separate. They're not being multiplied. There's no exponents, but we're not done because we can't have a fraction here. So we have 1/4 x minus 12y equals 1. To get rid of this fraction, I have to multiply this whole side of the equal sign by the denominator. So I got to do the same thing over here. So 4 times 1/4, the 4's cancel and I'm left with just 1x, minus 4 times 12 is 48, 4. So this would be x minus 48y equals 4. This equation is the same thing as this one, but I just don't have a fraction in front. Okay, if you have any questions on that, let me know.